everybody. Welcome back. This is our fifth time. Can you believe it? Fifth time together as we're going through our live exam boot camp. So we've learned so much thus far. If you have not been able to catch the last 4 sessions, go ahead, go back and take a look, and we're going to keep moving. Okay, now the thing about math is that you build on it. Okay, so sometimes I may say something in this session that you might not be familiar with, and it's because I've explained it more in depth in a previous session. So just keep in mind, if I say something that you're not familiar with, take just a small note on the side of your paper and then go back to the other videos and check out a more in-depth explanation of what I was talking about, and then that will give you an opportunity to kind of piece all of the puzzles together. Okay, so we are on YouTube, and today we're doing Facebook as well. But just a note for those who missed it, the last announcement for the next 2 weeks, which is going to be including Tuesday session and the following week, we're going to be on YouTube only. Okay, so for those of you who missed it, there was your opportunity to hear it. Okay, so let's get into our time together. All right, let's get into it. Okay, so tell me where you're tuning in from, okay? If you're in the Bahamas, if you're here in the U.S., where are you tuning in from? If you want to include your school, you can. That's fine. But welcome. I'm excited that you're here, and I'm excited for what we're going to go through today. So we did not get an opportunity to finish some of our the things we're covering last time. So we're going to finish that during this session. So it might be a little bit shorter. We'll see. I don't know. But just stay tuned. And as I mentioned in one of the earlier study tips in one of our previous videos, you can always pause the video. If you find yourself like drooping off or something, pause the video and take a break. Take a break and come back when you're a little more revived for another 20 minutes, and then go again and take a little break and then come back for the last 20 minutes. That's absolutely fine. Also, but if you're a student or learner who can do a full hour and you're good, then power to you, more power to you. Okay, so for my little disclaimer, which I say every time we get together, this is for informational purposes only. And that pretty much just means, for those of you who have not heard it before, these study tips that I give, or information that I give to you, these are proven tips, or even just the content I'm covering. These are things that you're going to see on these exams, or tips that you or people have used that have helped them to be successful in classes and help to boost their grades. And so they are scientifically proven, but it's up to you to decide whether you're going to go ahead and implement these things or not. I can't force it upon you, but I'm excited for those who do choose to say, I'm going to go all in. I'm going to practice these things and see what difference is made. I'm excited to hear your story. Okay, so how is this time going to go together? So we have our little open activity, which is going to be in a very short moment, and then we're going to reteach a few principles. So from there, we're going to do one exam prep tip, okay? And we're working our way through them. So if you're not sure what the other ones were, you can always zoom to the end of the videos on the last few sessions, and you'll see the study tip at the very end and some resources, okay? So for this, in the description box, you should see a link there to my website where I upload any worksheets, or if you're interested in any tutoring or just wanting to know more information, you can go ahead and check it out there at reteachlearning.com. All right, so what's our exercise today? We've been doing a lot of different exercises, and it's very interesting as I search for these different exercises, like what can we do because we're online? What can we do? So here's something that I think might pique your interest a little bit. And so here we go. So I want you to read what you see. All right, good. I'm going to go to the next one. Well, let's talk about this for a second. Most of you, when you saw this image, you read a bird in the bush. And then some of you noticed that the word "the" was printed twice. Now, what happens is your mind, literally as you're reading it, just skip past the repeated word. So that's a very interesting thing, how your mind just pieces together sentences, even though you might see a repetition, or maybe the words might not be in order, how it organizes information, huh? Well, let's take a look at the next page, okay? What do you see? Now, some of you see the word good. Some of you, if you're looking at the black writing, and some of you see the word evil if you're taking a look at the inside of the word good. And so like I said, your mind just pieces together different things. Some people are still not seeing evil, and some people are still not seeing the word good. But look a little closer, and you'll probably see it, okay? Now, the next one, you probably can't see this one really well. Yeah, oh, there it is, good. So, for some of you, you're seeing the word optical. And for others, you're seeing the word illusion, because it is an optical illusion. It's a play on the way you see things. And for some of you, you might need a minute and pause the video like, okay, I don't see the word optical. I only see illusion, or you might not see illusion at all. So just take a second and take a look at it, okay? We're going to keep moving, okay? All right, here we go. What do you see? Well, some of us see the word teach, and then others see the word learn. Teach and learn. If you don't see it, you can pause and then look a little closer. Take your time. And let's see. All right, so what's the point of all of this? Well, there was a beautiful quote I saw, and it says, and it's about perception, how we see things. It says, if I change the way you look at things, or better yet, change the way you look at things, and the things you look at change. Change the way you look at things, and the things you look at change. It's about perception, how your view of the world or view of your classes, since we're in like an educational setting or having an educational conversation. When you have a certain perception, for the most part, it affects everything. But if you change the way you see these things, in other words, instead of me seeing math as this horrible beast or monster, I developed an understanding of, okay, if I can conquer this, that it's something that I feel like is very difficult and hard, then I can conquer anything, right? If I can develop an understanding of something that I thought I could not understand, then, no matter what someone throws my way, I can overcome this, right? And so whatever is the most difficult thing you can think of, maybe math class is one of them, maybe athletics or whatever endeavor you want to pursue, I think this quote is very applicable. Change the way you look at things, and the things you look at change. All right, so that's our little activity. And so let's get into our lesson today. Okay, so we left off, we talked about percentages, and then we talked about hire purchase, which is in regards to consumer math and so forth, taxes, and what happens when we buy things that we can't afford. How do taxes or how do discounts or percentages work in those areas? And what we did not get to was discounts and markups, as well as wages and commission. So we're going to start here. Now, this slide came from our last time together, and it was talking about converting from percentages to fractions. So let's kind of review this a little bit before we keep moving, okay? So here we go. We have the 5%, and one of the things I mentioned is, and when I say I mentioned and you didn't hear me say it in this session, chances are it was in the last one. So one of the things we talked about in the last session was that a percent is simply a special fraction. It's a special kind of fraction because its denominator is always 100, okay? So if you see 5%, if I want to convert it to a fraction, I'm simply going to take the number part of my percentage, which is the 5, and I'm going to put it over 100, okay? So I have 5 over 100, and any percent, you can do that too. So if I see 20%, then that means 20 over 100. So there's that. And then we can go a little bit further. So I see 5 over 100, I see 20 over 100, but for the most part, if you gave this answer to your teacher, they would say, yeah, you're not done yet. Like, you can do something with this. You can break this fraction down a little bit further. You can, what we call, reduce or simplify this fraction. So for some of you, you're masters at this. You can do this in your sleep. And for some of us, it's a little bit more confusing, or you haven't quite cracked the code yet. So let's talk about reducing this a little bit. First of all, what I need to figure out, let's say I'm taking a look at the fraction 5 over 100. I need to figure out what is a number that's common, or what we call a common factor, that applies to the number 5, which is in my numerator, and the number 100, which is in my denominator. Now, it has to be the same number. So, in other words, what's a number that I can make groups out of in both of these numbers and not have any remainder? So, for example, if I use the number 5, well, I can make one group of 5 out of the number 5, and I can make 20 groups of 5 out of the number 100. So the number 5 is a common factor between both the numerator and the denominator. And so if I can find a common factor, then what I will do to reduce my fraction is I would simply divide my numerator and my denominator by that common factor. So let's see what happens. So 5 divided by 5 and 100 divided by 5. Well, what this will do for me is 5 divided by 5, or like I said before, there's one group of 5 in the number 5, and there are 20 groups of 5 in the number 100. So if I were to reduce this fraction, 5 over 100, it would be 1 over 20. All right, now you can try the next one for 20 over 100, and you can see if your answer lines up, okay? But I'm going to keep going. You can pause it here. All right, so 20 over 100, let's find a common factor. Now, if you look at 20 and you look at 100, you can say, okay, well, 5 can go into 20 and 5 can go into 100, and you would absolutely be right, and you can try that. You can say that 10 is a common factor as well. 10 can go into 20 and 10 can go into 100 without any remainders, and you would absolutely be right. But the highest common factor would be 20, because 20 can go into itself, or there's one group of 20 and 20, and there are 5 groups of 20 in 100, right? So that's the highest common factor. And what that does for me is it helps me to not have to reduce any further or simplify any further when I use the highest common factor. But if you used other factors that work, it's fine. Just keep simplifying until you cannot simplify anymore, okay? So let's take a look. So I said 20 was a common factor, so I'm going to divide both numerator and denominator by the same common factor, okay? It has to be the same number. You can't divide the numerator by one number and the denominator by another number and say, oh yeah, I reduced it. It doesn't work that way. It has to be the exact same factor. That's why the word common is in there. Common means that we share this thing, okay? So 20 divided by itself is 1, or there's one group of 20 and 20. And then 100 divided by 20 is 5. So in other words, there are 5 groups of 20 in the number 100. So with that being said, I'm going to erase these little division pieces for a moment. And I want you to take note of the heading. It says equivalent fractions. I wish my little highlighter was a little bit bigger, but the fraction 5 over 100 and 1 over 20, these are considered or called equivalent fractions, all right? In other words, if you notice, in order for me to get from 5 over 100 to 1 over 20, all I did was divide by a common factor. So when we talk about equivalent fractions, we're talking about fractions where we have common factors that can get me from one fraction to another. So 1 over 20 is a common is an equivalent fraction with 5 over 100. If I were to multiply 1 over 20 by another number, so let's say I decided to multiply 1 over 20 by 2, but I had to do it to both numerator and denominator. So 1 times 2 and 20 times 2, right? I would get 2 over 40. And it just so happens that 2 over 40, 1 over 20, 5 over 100, they're all considered equivalent fractions with one another, okay? So that's the concept I want you to understand, because we're going to use that as we keep going, okay? Similarly, when we have 20 over 100 and we reduced it to 1 over 5, well, 20 over 100 and 1 over 5, they're considered equivalent fractions. In other words, there's only a factor, like I just divided by 20 to get to 1 over 5. 20 over 20 specifically, okay? So why does this matter? Here's why. When you go to class and you get your grade back, let's say that you have 10 questions on your assignment, and you got a 70%. Earlier, I mentioned that a fraction is a percent is a special fraction that has a denominator of 100. So that's the same as 70 over 100, right? But on your test, you got 7 out of 10. Well, how can I get 70 over 100 if I only got a score of 7 over 10? Well, what you'll notice is if I were to divide 70 by 10 as well as 100 by 10, which is the common factor, I would get 7 over 10. And so 7 over 10, 70 over 100, those are equivalent fractions. And so that's where we see, or that's why we can pretty much switch between your grade of 3 out of 5 or 9 out of 11 and say, okay, this is equivalent to this particular percentage, because we're using equivalent fractions. And it just so happens that we can also use these equivalent fractions to help us solve problems relating to discounts and markups as well. So let's take a look, okay? So when you're solving percent problems, here is a little formula that can help with the majority of those problems, okay? So I'm going to show you how this relates to the example of you getting a homework or a test paper back. So the word part here, represents how much you would have gotten correct, or how much are we dealing with out of everything. So for example, if I ate 5 out of 8 slices of pizza, the part would be the 5 slices I actually ate, all right? And then the whole is representing, if you're looking at the case of your exam paper that you got back, the whole represents the maximum amount of points I could get altogether, which in the case of the paper, it would be 10 points. And then we have our equal sign that's sitting here. Now remember, these are equivalent fractions. On the left-hand side, I have a fraction. On the right-hand side, I have a fraction, and they are considered equivalent. In other words, there's just a factor of a difference between them. So on the right-hand side, I have my percent, which in my, what I can do is just write the numbers. The part was 7. I got 7 correct out of 10. And then that gave me 70% out of 100, all right? So how do we use this to solve discount problems and markup problems, right? Well, here's how we're gonna do it. By doing examples. And then you'll see how it's used, and you can practice it on other questions you may come across on the internet, or maybe questions you have from your homework, and see how it goes. Okay, now I will say this, math requires practice, and it also oftentimes requires you to ask questions if you're confused. So if you have a question for me, go ahead and ask it in the chat, or you can email me at reteachlearningllc@gmail. Once again, that's reteachlearningllc@gmail.com. Okay. All right. Let's keep going, and we're gonna practice this with some problems that we have. All right. So I have my little. All right. All right. So here we go. So these questions are adapted. They're not specifically exactly the questions that are on like BJC or BGCSE or SAT questions. I read those questions and I adapted my questions from those questions. So you'll see very similar questions on those exams as the ones that we're talking about, and then some of them are exact, replicas of the question. So let's go ahead and read. After a 10% cash discount, a car is on sale for $15,200. The car can also be purchased by making 24 payments of $755 each. All right, so that's a lot of information, and you can take that in, or you can read the question, the next part, and then go back to the information they gave to see how it applies. All right. Now, the first thing they ask, what is the original price of the car? What is the original price? Well, let's take a look at the information they told us. What they said is that after a 10% cash discount, a car is on sale for $15,200. So what that's telling me is this: the $15,200 is not the original price. Otherwise, they probably wouldn't ask you for the original price. The $15,200 is the sale price. In other words, that's how much they're going to sell it to you, but that's not the actual original price of the car. So this is the sale price. And notice it says after a 10% cash discount. So that tells me that the $15,200 represents only a portion of the original amount. Specifically, if we're talking about percentage, so for example, let's write down the formula and then we're going to apply it. So we have part divided by the whole, and this is equal to the percent over 100. Okay, so how do I fill this in? How do I fill in this formula into my, with the information it gave me? So the sale price is just a part of the original price. Okay, so if I'm going to put this in my formula, the sale price is going to be the part, so that's $15,200 over 15,200. Yep. Okay, and that's going to be over the original price, right? But we don't know the original price, so I'm going to use the variable x to represent what I do not know, and that's going to be equal to, now let's talk about the percent. We know that the 100 is going to stay there, but what number goes, well, because the 100 is just a part of the formula, okay? But what goes at the top? What goes in my numerator on the right-hand side? Well, the percentage that goes there is going to be the percent that's represented by the $15,200. What do I mean? Well, in the question it told you that after the 10% discount, the $15,200 is how much they're going to pay. So what that means is the person who's buying the car is only paying 90% of the full cost. Now, how did I get 90? Well, 100% is the, well, let's use, okay, here we go. So 100% represents the actual original cost of the car, right? But what they're saying is they took away 10% of it. So I have 90% left. And that's the 90% that I'm paying, and it's represented by the $15,200. Now, if you need to pause and play that again, go ahead and do that, okay? But I'm going to go ahead and put my 90% here because that's what the $15,000, so $15,200 represents 90%, and X is representing 100%, which is the original price, all right? Now, there was a point in time where I mentioned in an earlier video about cross multiplication. Now, I remember a time when I sat with someone, I won't say whether it was a student or not, but, and oftentimes the answer to the questions I would give was always cross multiply. And I'm like, no, cross multiplication is not the answer to every problem in life. Okay, so when do you cross multiply? Well, you cross multiply when you're dealing with equivalent fractions and there is an unknown that you're trying to find. So here we have a fraction, 15,200 over x, that's an actual fraction, and it's equivalent, in other words, there's an equal sign there, to another fraction. And so this is where I can use cross multiplication. All right, now I haven't seen cross multiplication used in any other way or at any other point unless we have equivalent fractions. So I'm going to go ahead and make some space here, and let's go ahead and do the cross multiplication. Okay, here we go, let's go. So how does cross multiplication work? Well, cross multiplication, how we work it is we multiply the diagonals. So 15,200 is going to be multiplied by 100. So 15,200 multiplied by 100. And that's going to be equal to the product of the other diagonal, which is x times 90. All right. Now, are there other ways that you can tackle this? Absolutely. Times 90, or 90 times x, same thing. Now that we have this, we're going to do the math that they tell us to do, okay? So, and then, of course, if you have not seen our video that talks about solving equations, you want to take a look on that because this is what we're going to do here. We're just going to solve for x, all right? So the first thing we do when we're solving equations is we simplify if we can. So what do I mean? On the left-hand side, it says 15,200 times 100. So what's that going to give you? That's going to give you 152,000. And that's equal to 90 times x is simply 90x. Now we want the x by itself because the x is going to represent the original price. And so in order to do that, we're going to do the opposite of what we see. What do I mean? 90 is being multiplied by x. And so the opposite of multiplying by 90 is to divide by 90. And we must do it on both sides. Okay? So x is going to be equal to 16888.89. Now, you can round it if you want to. And I wish I could write a little bit bigger, but zoom in your screen if it's too small, okay? But this is what I did, okay? And I'm going to use the same process wherever necessary when it comes to dealing with discounts and markups, okay? But this is the original price of the car. It's actually $16,888.89. All right, now it says calculate the amount of the cash discount. That's the next question. How much is the cash discount? Well, I just figured out what the original price of the car is, and I know what the person bought the car for, so all I would probably need to do is subtract them. I can subtract them. Or you can use the same process we just used again, except instead of using the 90%, you can, you can use the 10% and so forth, but we can just subtract them. That's the most straightforward way to deal with this question. So we have the 16,888.9, 0.89 or 0.9. And that's going to subtract the 15,200. All right. I have my little handy dandy calculator here, just in case. 16888.89 minus 15,200. And that's going to give us 1688.89. All right. So that's the discount she's going to get, or this person is going to get, if they paid cash. Okay. All right. Now it says calculate the cost of the car using the payment plan. Let's say you cannot afford the car, which is the case for most people. They'll probably use a payment plan. And the payments plan says I'm going to spend $755 for 20, or spread 24 over 24 months, or 24 payments of $755. So what does that mean? Well, the first payment is going to be $755. The second payment is going to be $755. The third payment is going to be $755. Some of you are like, I get it. You could stop now. But for those of you who really didn't get it, what I'm saying to you is this. Whenever you hear a number being repeatedly added over and over again, 755 plus 755 plus 755, that's an indication that we're dealing with multiplication, all right? Because multiplication is repeated addition. So a shortcut for you, instead of adding 755 24 times, which is probably going to take you a long time, you can just multiply 24 by 755. All right, so 24 times 755. All right, so 755 times 24. That's going to give you, and let me do that one more time, 24 times 755. All right, that's going to be $18,120. All right, so there you go. Now it says how much is saved by paying cash? How much is saved by paying cash? Now with this one, we're comparing how much we would pay by if we did the payment plan versus paying cash. So if we did the payment plan, we would pay $18,120. And if we paid cash, we would pay $16,888.89. Okay. So how do I know how much is saved? Well, I'm going to simply find out what's the difference between them. I'm going to subtract those two results, okay? So 18,120 minus 16,888. Don't forget your 89 cents. And that's going to give you $1,231.11. All right, so that's how much is saved. And that's how you would do a problem like this if you saw it on your exam. Yeah, you finished it. Good job. Okay, good job. Now, are there other ways? Yeah, there are, but I can't explore all of them during our time, but what I can do is give you maybe one tool that you can use consistently and get similar results, okay? So let's take a look at another example of when we're dealing with discounts or markups, okay? This is also from a paper, BJC paper. Now, some of you who are doing BGCSEs or maybe SATs might be like, well, where are the questions from the SAT or the BGCSE? Here's the thing. An exam like the BJC really sets a really good foundation for those other exams as well, because you'll see similar concepts repeating themselves because math builds. So if you can understand these basic concepts that are on the BJC or maybe like a GLAD exam or something, then that's going to help you to pretty much understand even more advanced concepts that integrate these different ones that we're going through here. So that was a lot of big words for some people, but all I'm saying is if you do well here, it's going to help you do well later, okay? Example number 2, the original price of a chair is $140. The original price is $140. A discount is given and the price drops to $105. Okay, cool. Find the amount of the discount given. All right, perfect. Now they want to know the amount. So this is an indication that they're just asking me, okay, how much money did they not have to spend, right? So all I'm going to do is subtract those values. The original price is $140, and I'm subtracting from that the new cost, since the price dropped, to $105. All right, so $140 minus $105 is going to give me my $35. So that means that I have a $35 discount, which is pretty cool. All right. Now, next question. Express the discount as a percentage of the original price. Did you hear that? Express it as a percentage of the original price. Specifically, the discount as a percent of the original price. So what do? Well, the discount is $35 and the original price is $140. Okay, $35 and $140. Now, I don't know if you remember our formula, which said part over the whole is equal to the percent over 100. We can use the same concept here, all right? So 35 is the discount, 140 is the whole, that's the total cost of the item. That's equal to, we're trying to figure out what the percentage in this one is. So we're going to just put X here over 100. Now, for some of you, you're like, oh, we can just multiply by 100, and you're right, and we're going to get there. But let's see the why, all right? So let's do the math. So we can use cross multiplication here because we have two equivalent fractions, right? We're not just randomly doing cross multiplication because we feel like it. It's because the question actually says, oh, I'm allowed to do it based on the setup we have. We have one fraction that's equal to another fraction. All right, so how do we do that? We multiply the diagonals. So 35 times 100, 35 times 100, and that's going to be equal to X times 140. So 140 times X. All right, so let's do the math. On the left-hand side, 35 times 100 is going to be 3500, and that's equal to 140 times X. And then I want to get the X by itself. So I divide by 140. And why do I do that? I divide by 140 because 140 is what's the problem. It's in the way of me getting the X on its own. But it's also true that 140 is being multiplied by X. And when we did our lesson on solving for equations, we said that we have to do the opposite operation. So the opposite of multiplying is to divide. So instead of multiplying by 140, we divide by 140. All right, so 140. All right, so let's go ahead and do the math. On the right-hand side, 140 divided by itself is just 1, so we end up with X over there. And then on the left-hand side, we have 3500 divided by 140. And that's going to be 25%. Okay, now you're going to get the same answer if you divided 35 by 140 and multiplied it by 100. That's like the shortcut. But for the most part, those of you who know the shortcut, now you know why. Okay, you're not just doing it because you can. You're doing it because there's a system behind it. And if you understand the system, you can apply it to any problem you have, not just, straightforward questions. All right, so let's take a look. Any other examples? Let's see. Number 3. Okay. Now, what we have talked about so far was dealing with discounts. But what happens when we're dealing with a markup? Can we use that same formula process for markups? And the answer is yeah, we absolutely can. So I'm going to write it here. I should have kept it on the screen, but I have part. I'm going to put P for part, W for whole, and that's equal percentage over 100. Okay. All right, so let's look at the question. It says a shopkeeper, let me go ahead and, there you go. A shopkeeper buys an oven from a manufacturer. Now, this question came from a student that I worked with. Liked the question, so I brought it here. Okay, so you may see this in one of your textbooks. A shopkeeper buys an oven from the manufacturer. The shopkeeper sells the oven for $2,500 at a profit of 20%. Okay, cool, awesome. Now, first question says, what amount did the shopkeeper pay the manufacturer for the oven? Now, if you see stove and oven like going back and forth in this question, it's because it's an adaptation, but I guess I must have missed it, okay? So, no judgment, please, and thank you. All right, so here we go. What amount did the shopkeeper pay the manufacturer for the oven? So we're going to use the same formula that we used in the earlier examples. The first thing that we want to note is that it says that the shopkeeper sells the stove for $2,500. Okay, so he's selling the stove for that much, $2,500, at a profit of 20%. So what does that tell me? Well, what that's telling me is that the $2,500, that's not the original price. That's just the price he's selling it for. Okay? Why do I know that, or how do I know that? Well, first of all, he's a businessman. For the most part, people don't buy things and sell it for the same price unless they realize that they have to or they don't have a choice. In his case, it said that he has a profit. So that's telling me that the $2,500 is considering that, he bought it for a certain price, he added on a couple extra dollars, and so forth. So what does that mean in terms of my my formula? The part is the 2,500, and the X on the bottom is the original price, the price that he bought it from his manufacturer, which we don't know, but we got to figure it out. Now, the next part is, or the next side, it says percent over 100. So we know that the bottom number is going to be 100, but what about the top number? Well, whenever you're dealing with a profit, that's telling me something about the percent. It's telling me that, okay, he got 100% of what he paid for the item, plus another 20%, which was his profit. So what does that mean? That means that the $2,500 on the left side is actually representing 120%. All right. Now, the question is, for some of you, oh my God, how are we getting 120? I'm going to say it one more time. Okay, and you can repeat this part. The reason why we have 120% in the numerator on our right side is because the $250, the $2,500 or $2,500 is 100%, which is what he actually paid, plus a 20% profit. So the 2,500 is actually representing 120%. Okay, so take that in, and we're going to keep going. Now, we're going to do our cross multiplication as again, okay? So we're going to multiply our diagonals together. And so I'll have 2,500 times 100, and that's equal to 120 times x. Now, some of you can literally zoom past this step because you understand how this thing works, and that's absolutely fine, okay? The reason I'm going through this long process is because I understand that there's some students here that really have challenges with understanding this part, and there's nothing wrong with having the challenges. But when I'm teaching, I want to make sure everybody's catching up, right? And at least you can take it further from there. But the basics are important.
All right, so let's go. So 2,500 times 100 is 250000. That's equal to 120x. And then I need to get rid of the 120 by dividing by 120. All right, so we have 25, 0, 1, 2, 3 divided by 120. And we get x is equal, let me move these things up a little bit. All right, $2,083.33. Okay, so this is how much he actually paid the manufacturer for the oven or the stove, whichever one you want to put in there. All right, so he made a good profit, and that's pretty good. Let's take a look at the next part of the question. It says, if the shopkeeper gives 10% discount for cash, what amount does the customer pay for the stove? Okay, now what is this telling me? It's saying the shopkeeper is giving 10% discount of what amount? The 2,500. Okay, now can you use the same process for that we used in part 1 here? Absolutely, you can. Okay, but the shopkeeper gives 10% discount for cash. What amount does the customer pay for the stove? So you can use this 10% of that and then figure out what the discount is and then subtract it from the original price. Or we can go ahead and simply use the process that we've been using before, and that's what we're going to do the long way. The long way. All right, so the shopkeeper gives 10% discount. What amount does the customer pay? So we're trying to figure out what part of the original price, or what part of the, the price that's on the tag, what part of the whole. So X is the part the customer pays, and the bottom is our whole, which is $2,500, is the customer paying. And then on the right hand side, we have our percentages over 100. Now, the question is, what percent goes here? Well, in terms of the X, notice that there's a 10% discount. So that's telling me that the customer is only paying 90% because the other 10% has been taken away. When we're dealing with percentages, in terms of figuring out, if we're doing percentages in terms of figuring out, okay, how much is left from the 100% that's there, then we just simply subtract them. So 100 minus 10 gives you a 90. So 90% is what the customer is paying. They're paying 90% of the original cost. So you can use the same process for this one and cross multiply. So we're going to multiply our diagonals again. So here we go. 90, let's move this a little bit. Okay, so we have 2,500 times 90, and that's equal to 100 times X. Okay, so 2,500 times 90, 2,500 times 90, that's going to give you 225,000. It's a big number. 100 times X, and our last step is to simply divide both sides by 100. So X is equal to 2250. And of course, this is money, all right? So I don't know if they take off points these days for you not putting the money sign there, but you can make sure you just put it there for a good practice. All right, next part and last part of this question. If the shopkeeper sells the stove at a loss of 10% of the cost price, determine its selling price. That's important information. He's selling it at a loss of the cost price. In other words, a loss of the price he actually paid for this stove or oven. So let's take a look at the numbers so we know what numbers we need to use, because when you have an exam and there's so many numbers involved, you kind of get confused along the way. So let's just take our time. So our formula says P, which is the part over the whole, and that's equal to the percent over 100. So what are we dealing with? It says here, the shopper sells the stove at a loss of 10%. Now, if you want, you can deal with the percent part first, or deal with the money. But if he's selling it at a loss, that means that the customer is only paying 90% because it's taking off the 10%. So on the right hand side of my equation, I should have 90 over 100. Okay, now the 100 in the denominator, once again, that's just a part of the formula. That doesn't go anywhere. But considering the 90 sometimes can be a bit confusing. But the 90 is asking you, okay, how much, at least in this example, what percent is the customer actually paying? And that's 90%. So now let's take a look at the left-hand side. We need to figure out which number represents the 100%, right? So the question says, the discount is on 10% of the cost price, which is the price he paid the manufacturer. So 100% will represent the price he paid the manufacturer, which, if we go back in our question, was the $2,083.33. All right, so the 100% in here, in this question, is talking about the cost that he bought the stove or oven from the manufacturer. So what does that mean? That means that I need to figure out what the customer paid. All right, what's the selling price? And that's going to be my X. Now, when we use this formula, one of those fractions, or one of the areas in the fraction, is going to be missing. It's either that they're going to be missing the part, and you need to find the part, and you have all the other information. Sometimes you're given the percentage, or you need to find the percent, and you're giving everything else. Sometimes you have to figure out what the whole is, and you're given everything else. And all of that takes us reading the question and understanding what's going on. So now we can do cross multiplication here. Now, some of you, like I said, you might not have to do cross multiplication. You can use a different method. But what I want you to get in your mind is cross multiplication can only be used in certain situations. Not every situation, but when we're dealing with equivalent fractions, that's like you can go cross multiplication all day and you'll be good. Okay? Once you do it right, anyway. So we have $2,083.33 multiplied by 90, that's our green product, and it's going to be equal to 100 times X. Okay, so $2,083.33 times 90, and that's going to give us 187,499.7, and that's equal to 100 X. And we do our last step, which is to divide by 100. So X is going to be equal to $1,875. Okay, so that's your final answer at the end. Okay, now that's a lot of writing. It's a lot of writing, but a question like this is actually worth a good amount of points on your exam, which is really good, and which is why it's important to learn how to deal with problems like that, or like this one. All right, so let's see if we can get through the other ones. I think this, oh, yeah, there we go. So we just finished discounts and markups. Now, I would advise you to practice this as many times as you can, because practice makes better, okay? Now, the reason I don't say perfect is because everyone can make mistakes here and there, and it's fine. But I do think the more you practice, the more comfortable you're going to get. And if you're someone who struggles with test anxiety, practice and preparation is key to helping you overcome that, okay? So let's take a look at wages and commissions, and then we're going to be going to our study tip, and then we'll be done, all right? So we did a good amount of examples about when it came to discounts and markups. So you have some, tools to help you to figure out how to use that formula over and over again if you want to use that formula, or just questions to practice on your own time. So here we go. Larry Lugg earns $9 per hour. We're talking about wages now. When he works a basic week of 40 hours. They want us to calculate the amount of his basic weekly pay. All right, so let's take a look at what's going on. It says he earns $9 per. So for every hour he works, he earns $9. So what does that mean? And it says he also works 40 hours a week. So what that tells me is for the first hour, he gets $9. For the second hour, he gets another $9. For the third hour, he gets another $9. Excuse me. And so if he works 40 hours, he's going to get $9 every time. And you probably picked it up already that we're repeatedly adding the same thing over and over again. And whenever we add something repeatedly, that is an indication that we need to just multiply, okay? So we have $9, sorry, $9 multiplied by 40 hours. And that's equal to $360. All right. So if he works 40 hours, he's gonna get $360. Okay. Now let's keep going. And some of you are like, why does she keep repeating that? It's because I want you to dream about it. Okay. the more we expose ourselves to things, the more we're likely to remember it and be able to recall it. Number 2, it says overtime is paid at time and a half. Now, some of us, sometimes when we read this, we're not sure what they're trying to say. So time and a half, what does that mean? Time and a half just means 1.5. What do I mean? When you work overtime, what they say is, okay, we're going to pay, if you work for 1 hour overtime, we're going to pay you like you worked an hour and a half, an hour and 30 minutes. That's what they're saying. If you work, sometimes they'll say time and a half, sometimes they'll say double time. Double says if you worked 1 hour overtime, we're going to pay you as if you worked for 2 hours. So whatever you would have earned in 1 hour, being paid at double time means you're going to earn twice that much just for 1 extra hour of work. And that's why some people like overtime. But in this case, it's just saying that I'm going to pay you like you worked an hour and a half. So let's look at the next part. It says, how much does she earn for 1 hour of overtime? How much does she do? So let's consider. For 1 hour, she would earn $9. But they're going to pay her $9 plus 1/2 of $9. Okay, so if you want to cut that in half and figure it out, you can. But what you can do is to figure out how much is for overtime pay, you simply multiply 150, so that's 1/2, by how much she's going to earn, which is the $9. So 9 times 1.5. All right. So the 0.5 just represents the half of 9 that she's going to get, plus the 1, or the full $9 that she's going to get for that 1 hour. So 9 times 1.5, 9 times 1.5, and that's $13.50. So if she works overtime just for 1 hour, she's going to get $13.50 for that 1 extra hour of pay, which is really cool because, well, she's getting more than the $9 she would get if she'd only worked during the regular hours. So let's see what part 3 tells us. It says calculate Larry's, well, is it she? Is it he? Calculate Larry's total wage for the week if he worked 6 hours of overtime in addition to his basic hours. So let's take a look what's going on. He's working in addition to his basic hours. So that means that I need to figure out his basic hour work week. So we already figured that out in part 1. So that's $360. Plus, now we need to figure out his overtime. What they told us is for overtime, he's going to be paid $13.50 for every hour. So what that tells me is once he hits overtime, for the first hour overtime, he's going to get $13.50. For the second hour overtime, he's going to get $13.50. I hope you picked it up that we're adding the same $13.50 every time. So that's multiplication. So we're going to add $13.50 multiplied by the 6 hours he worked overtime. Okay, now you can take that in, breathe a little bit, don't run away. But let's do the math, okay? So 360 plus, now let's do $13 times 6. $13.50 times 6 is 81. So he's getting $81 just for the overtime pay, plus the 360, and remember the 360 is just his basic pay, is equal to $441. All right, so that's how much he's going to get for overtime pay, and that's how we work overtime, or that's how we calculate overtime pay. Okay, we have another example for you, or I have another example for you. Okay, now Miss Lisa, she's paid $8.50 per hour when she works a basic 40-hour week. Overtime is paid at double time. Calculate her basic weekly pay. So the basic weekly pay is going to be the $8.50 for 40 hours. $8.50 per hour for 40 hours. So once again, hour number 1, she gets $8.50. Hour number 2, she gets $8.50. Hour number 3, until she gets 40 hours, she's getting $8.50 every hour. So we're multiplying. So $8.50 times 40. 8.5 times 40, and that's going to be $3.40. Okay. Now it says calculate her pay for 1 hour of overtime. And this is where we take a look at what they say about overtime. It says overtime is paid at double time. So double time means if you work for 1 hour overtime, and when I say overtime, you work 40 hours originally, but if you work 41 hours, that extra hour is considered overtime, okay? For those of you who are not sure about what overtime is. But if you work if you work 41 hours, that 1 hour extra that you worked, we're going to pay you double for it, okay? So what does that mean? $8.50 times 2. That's going to tell me how much she's going to earn just for that 1 hour of overtime. All right, and that's going to give me $17. All right, so every hour overtime, every hour over the 40 hours she works that week, she's going to get $17. So it says calculate the total pay for Mrs. Jones' 40-hour work week. 48-hour work week. Okay, so she's working 48 hours. Now, let's go back to the top of the question. It tells us that her basic work week is 40 hours, but now she's working 48 hours. So what does that mean? That means that for the first 40 hours, she's earning $8.50 for 40 hours, okay? After that, she has an additional 8 hours that are going to be calculated at overtime because that's not the hours she's supposed to work. She's working additional time, so they're going to pay her additionally. And what they said is that we're going to pay you $17 for the extra 8 hours that you're working. All right, and we're going to add those together. Now you can take a breath and replay that part if I lost you anywhere. But let's do the math. 8.5 times 40, that's going to be $340. Plus, now we're doing overtime. 17 times 8, that's going to be 136. Okay, so now we're going to add them together to see what the total is going to be, and that's 476. Okay, now you can calculate it. If my number is a little bit off, forgive me, please. Don't stone me. But just calculate it, okay? Now, with that being said, we're going to be out of time, so we're not going to get to the last example. But what I'm going to do is I'm going to put it up for you. I want you to make sure this is the last one, okay? So take a screenshot of this and practice this. And when we meet again on Tuesday, we're going to pick up here, and then we're going to keep going. Now, we've done a lot of word problems. We've done a lot of equations, a lot of expressions, and all these different things. And so we're going to get into the heavy hitters on these exams for the rest of our time together. We're going to talk more about geometry, which has to do with angles and different geometric shapes like parallelograms and so forth, and how to deal with those things. Now, we're integrating what we've learned about equations to solve for different angle measures and so forth. So you want to be here for that if you're not really good, or if you feel like you're not really good at angles and triangles. You want to be here for that, okay? Another heavy hitter, and when I say heavy hitter, the things that really take a lot of the grade or the scores on these exams have to do with charts, how to read different kinds of charts, statistics. Do you know what they mean when they ask you for the mean or the median and the mode and the average? Do we know what they mean and how to do those? We're going to talk about it. And plotting is another part of it. So graphing when it comes to transformations like reflecting or translation. If those words don't sound familiar, my friend, you don't want to miss it, okay? Now, keep in mind, like I said, we're going to be live only on YouTube starting Tuesday. And so go ahead. If you're not on YouTube already, go over there, subscribe, like, and share so you don't miss a beat, all right? So this is your muscle work between now and Tuesday. And here's your study tip before we leave, okay? Study tip number 1 to improve your grades, it says you can use flashcards. Now, some of you are like, I already use flashcards in other classes. How can I use flashcards in math? Well, in one of our very first sessions, I said to you that vocabulary is important. So if anything I've said as we've been sitting here together in this session didn't make any sense to you at all, then the reason is because vocabulary is something where we might be lacking in. And it's okay to be lacking, but it's also better to fill in wherever you might feel like there's lack. Okay, so a flashcard, what you'll do is you'll just get, and you don't have to buy them. If you have sheets of paper, you can cut them into tiny squares. On the front, you'll put the word. On the back, you put an example of that. So, yeah, and then that's a flashcard. Or you put a word and you put the definition on the back. Sometimes what I used to do is I'll put a question, like an actual equation or a question, and then I'll work out in my head how to solve that question, and I'll turn around and see if my thought process for solving it matched the answer on the back. Or I'll put the question and I'll write the answers or the process for getting to the solution, and I'll match it and see, oh, okay, good, I know how to do this. And so that's a good way to help to improve your study habits and help you to improve your grades over time. So, great for vocabulary, remembering steps to problems, etc. So a lot of things. So now, with that being said, we're done. We are done. I'm so excited you're here. And I'm looking forward to talking about angles. I know some of you hate them, but those things make me excited because I like putting puzzle pieces together. And I'm so excited to be on this journey with you as we, navigate through different ways and processes of how to get from the problems we're facing to the solution. And this is a part of the experience. So I'll see you all on Tuesday. And once again, we're going to be on YouTube only. Okay, so go ahead, at Reteach Learning on YouTube. Like, share, subscribe, and leave a comment so I know you're here. And also, if you're interested in more information, or even some people have asked me about tutoring, go to my website, reteachlearning.com, and you'll learn more there. All right, so I'll see you later. Bye.